In number 1, we're given a parallelogram, and we also know that AF and DF are congruent, so I'm going to go ahead and mark those. So right away, as soon as I mark those, I see that I have an isosceles triangle here, so I know that these base angles are going to have to be congruent. And I also know angle R is 122 degrees, and we're trying to find AFD. So AFD is this angle here. So because we have a parallelogram, we know that opposite angles are congruent. So that means if this angle is 122, the angle down here is also 122, which then from there, since these two angles are supplementary, I can subtract from 180. So 180 minus 122 gives me 58. So that means that these two base angles are going to be 58. And then to find angle AFD, all I need to do from there is I'm going to say, well, since I have a triangle and I know the two base angles are 58, I'm going to do 180 minus the two 58s. And that'll leave me with the vertex angle, which is 64. So that means the measure of angle AFD is 64 degrees. The next example here is a coordinate proof. So we're given this quadrilateral, so I'm going to start by plotting. So 0, 2 is P, Q is over 4 up 8, 7, 6 for R, and then 3, 0. So here's my quadrilateral, and I'm trying to prove that it's a rectangle. So right away, if you're trying to prove a rectangle, it should look like a rectangle when you plot it. So if you're not plotting it and getting a rectangle, it means something was plotted incorrectly. So since it's a coordinate proof, we're going to write a plan, and then we're going to do the math, and then we're going to have a conclusion. So if I'm trying to prove that this quadrilateral is a rectangle, if you think about the flow chart, what you have to start with in order to go from a quadrilateral to a rectangle is it has to pass through a parallelogram. So I have to prove one of these properties and then one of the unique rectangle properties. So the easiest way I think to do this is going to be to show that opposite sides are parallel, and then knowing that I have a right angle is going to mean that I have a rectangle. And I don't have to show that all four angles are right angles, because if I know that it's a parallelogram, well, then opposite angles are congruent anyways. So that would give me, if I know that this angle is a right angle and it's a parallelogram, well, then that means this angle is a right angle. And then I also know consecutive angles are supplementary, so these two would have to be right angles. So really, all you have to prove is opposite sides are parallel, and then show that one of the four angles is a right angle, and that would mean all of the other angles are right angles. The reason why I'm going to choose opposite sides are parallel is because I know I'm going to need slope formula to show a right angle, so I might as well do slope to show parallel and then just use the results to show that I have a right angle. So if we go back, I'm going to say use slope to show opposite sides. So use slope to show opposite sides are parallel and show one right angle. So for the slope, for the math step, it's up to you if you want to use the actual slope formula, which is the change in y's over the change in x's, or just count it out. I'm going to guess that most of you would prefer just to count it, so that's the way that I'll do it. So I'm going to find the slope of the opposite side, so I'm going to start with PQ. So I'm going to count how much I have to go up and over. So I had to go up 1, 2, 3, 4, 5, 6. So it's up 6. And then it's right 1, 2, 3, 4. So this means it's going to be positive 6 over 4. Remember, you always want to count to the right. That way, if you go up, it's positive. If you go down, it's negative. And then if you reduce this, it would be 3 over 2. So then I'm going to do the side opposite that. So because I want to make sure that those have equal slopes to show that they're parallel. So if I count, it's going to be 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So again, up 6, right 4 would be positive 6 over 4, which would reduce to 3/2. So this shows me that PQ is parallel to SR because same slopes, because they have the same slope. And then I'm also going to do the same thing for the other two sides. So I'm going to find the slope of PS. So this is going to be down 1, 2, then right 1, 2, 3. So down 2, right 3 means it's going to be a negative 2/3. And then I'm going to look at the slope of QR. And remember, we're always counting to the right. So I'm going down 1, 2. And again, over 1, 2, 3. So that is also negative 2/3. So that proves that PS is parallel to QR, again, because the slopes are the same. So that proves it's a parallelogram. Now, if I want to prove that it's a rectangle, I have to show that there's one right angle. So we can just pick any of the angles and show it's a right angle. So I'm going to pick angle P and show it's a right angle. So if angle P is a right angle, that means that these two slopes must be negative reciprocals. So the slope of PQ is 3 over 2. The slope of PS was negative 2/3. Make sure you write M in front of it because it's not the measure, it's the slope. So it's the slope is negative 2/3. So these are flipped and negated. So that means angle P is a right angle. So basically, I'm just going to write that. So I'm going to say angle P is a right angle because I'm going to say the slope of PQ and the slope of PS are negative reciprocals, flipped and negated. So now I can write my conclusion. I can say that I have a rectangle because it has opposite sides are parallel and one right angle. So therefore, quad PQRS is a rectangle because opposite sides are parallel and it has one right angle. It wouldn't be wrong if you wanted to prove more than you had to. So let's say you weren't sure if I should prove one right angle or all four right angles. Well, then just prove all four and you'll be safe. You could also prove opposite sides are congruent. That might be what you think of when you think of a rectangle, and then use the slope formula as well to prove that you have four right angles. It's not wrong to do that. I just try to do it in the shortest way. So this is just one of many ways to prove that this quadrilateral was a rectangle. And then the last proof on this page is looking at a Euclidean proof. So this is where you have your two columns. So I'm going to start with my two columns here. And we have our statements. So I'm going to write my givens. So statements, reasons. So we're given a parallelogram. We're given AC is congruent to BC. And we're also given two angles are congruent. So we know we have a parallelogram, so that means we have a lot of properties. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. So there's all those properties from the flowchart. I know that these two segments are congruent, and I know angle 1 and angle 2 are congruent. As soon as I label angle 1 and angle 2, I look at this as an isosceles triangle. So I'm going to go ahead and state that, because if that's isosceles, it means I have two congruent sides. So let me write given here first. So I'm going to state that we have an isosceles triangle. So triangle ECB is isosceles. And that's because a triangle with two congruent base angles implies isosceles triangle. And then from there, that means that side BC and side EC are congruent, because if we have an isosceles triangle, then we have two congruent sides. And then if you notice, well, if AC and BC are equal and BC and EC are equal, then all three are equal. So really, what I care about is the fact that these two sides are congruent, because if we have two congruent consecutive sides in a parallelogram, that makes it a rhombus, because then that really makes all four sides equal, because in a parallelogram, opposite sides are congruent. So if opposite sides are congruent and these two are congruent, well, this side equals this side equals this side, means all four sides are equal, so it's a rhombus. So my sixth step is going to be to say that these two sides are actually equal to each other. So AC is congruent to EC. And that's going to be by substitution. Or you could say transitive property, or you could say if you have two sides that are equal to the same side, then those two sides have to be equal to each other. If you look, I have BC being used twice, so that would mean that AC and EC have to be equal, since you have two things equal to the same thing. And then the final statement here is to say that we have a rhombus, is to say ACEF is a rhombus. And the reason for that is because a parallelogram with two congruent consecutive sides, meaning in a row, is a rhombus, or implies rhombus. Now, keep in mind, if you didn't know that reason, because that's kind of like the shortcut reason. If you didn't know that reason, you could have said, okay, well, since AC and EC are congruent, well, now I can show AC and EF are congruent. I could show that those are congruent because opposite sides in a parallelogram are congruent. I could also show that EC and AF are congruent because opposite sides in a parallelogram are congruent. And then this is a rhombus because all four sides are equal. Going back to the flow chart, whenever you talk about proving, if you're trying to prove that you have a rhombus, well, you had to first, we started with a parallelogram, so I only had to go through from a parallelogram to a rhombus. I didn't have to jump through another quadrilateral. So the only difference is I had to prove one of these properties. I proved the sides are congruent. I just did it in a shorter way because I knew since it was a parallelogram, the opposite sides were already congruent. So instead of saying all four sides were congruent, I covered that by just saying consecutive sides, because that would automatically imply that all four are equal since the opposite sides are congruent. Because if these are congruent, well, since it's a parallelogram, opposite sides are congruent, which makes all four congruent. So I kind of proved that, or I did prove it, but I just proved it in the shortest way possible. Like I said, it would have been fine if you actually went through and you made the statements that these two sides are congruent, these two sides are congruent. Because it's a parallelogram, opposite sides are congruent, and then you can wrap it up and say it's a rhombus because all four sides are equal.